Well, welcome back, viewers. Welcome back to Brain Data Science. This is a part 2 of the video series on electrolysis, helping us to understand how to calculate, or how to do calculations on what now? Electrolysis. Okay. So now, if you are looking, the part 1 is what introduction. Is to just introduce us to what, just about the introduction of what electrolysis. You can look at that video on our channel. But with that being said, let's come back to this. And in today's video, we're going to be dividing into two parts. We're going to be talking about the what Faraday's law and Faraday's law of electrolysis and what the term here Faraday means. Like Faraday in terms of what now? A variable in what calculating what electrolysis. Okay, in terms of what quantity of electricity. So about that being said, let's talk about the first part. So now we have the laws of what electrolysis was postulated by a scientist known as Micheal Faraday. Okay, there are two, and those two laws were postulated by what Micheal Faraday. Okay, so now the first law of Micheal Faraday was that first Faraday's law of what electrolysis, the first law states that what now the mass of the substance that is discharged, that is deposited or discharged at the electrodes. Of course, by this time we should know what electrodes are. The mass of the substance discharged in the electrodes during what now electrolysis, that's the electrolytic process. The mass now is directly proportional to the quantity of electricity that is what coursing through the what electrolyte. The quantity of electricity that is what now passing through the electrolyte. So now the mass of the substance discharged at the electrodes during the electrolysis is directly proportional to what now the quantity of electricity that is what passing through the electrolyte or coursing through the electrolyte. Okay? As usual, we all know that when we this is a variable sign, when we want to introduce an equality sign, there must always be what now a constant of what now proportionality. Expression that we have here, this expression that we have here now. If we should introduce a constant, there's a constant for it actually. Since this is a direct proportionality word sign, the mass of the substance can be equal to ZQ. Okay? At this point, the Q here is what? Representing what? The quantity of electricity. Then here is representing what? The mass. Okay? Okay, but now also remember from electrostatics, or let's say current electricity, movement that's movable charges, that's current electricity. Quantity of electricity can be measured. Or like it's a measure of what now? The current multiplied by what now? Time. Okay? I say IT, current multiplied by what? Time. So now that means this particular equation that we put now, the particular equation that we have then can also be written as what now? Mass, let me come here. The mass equal to ZIT. Okay? So now, what does this Z represent? This Z now is what? The constant of what now? Proportionality. Okay? And the Z is also known as what now? The electrochemical constant. It's a constant, that it's an electrochemical what? Constant. Okay? Electrochemical constant, and the constant of what now? Proportionality between the mass of the substance. Provided this electrochemical provided there is a constant, the mass will always be equal to what now? The what quantity of electricity. So now as the quantity of electricity is increased, that means that as the quantity of electricity that is entering the electrolyte increases, the mass that will be deposited will also what? Increase. That's what the electrolytic sign is. So now from this we can get this formula. Okay? That's what simply means. So now the second law of electrolysis, this second law of Faraday's law of electrolysis is actually comparing. You already know what an electrolytic cell is, or a voltammeter. I explained it in the previous video. So now, when you have two of those, okay, let's say two or more of those electrolytic cells, whereby the substance that is being decomposed in its molten or aqueous solution, we have three different types, or let's say two for instance. We have two different types, and we connected them together. The same quantity of electricity is passing through them. By the time we pass the same quantity of electricity through the both of them simultaneously, something occurs. What occurs is what this second law is trying to describe. Okay? So now, this Faraday's second law of electricity states that what now? If the same quantity of electricity is passed through various electrolytes, that means more than one, or maybe up to three, more than one, but that's more than one. If the same quantity of electricity is passed through what? Various electrolytes. It therefore means that the relative, that is, we are comparing them together now, the relative numbers of moles of the substance deposited will be inversely proportional to the ions on their charge. So what does that mean? That means the relative numbers of moles. That means when I say relative, when we say relative, it means you are comparing two or more things together. the relative numbers of moles of each of the elements, or each of the atoms deposited in the what electrode, will be inversely proportional to the charges on their what ion. Charges in this case is what now represented by the E here. This is what the law is about, the second law. Okay. Remember, if we also introduce this n now, where this n now is representing what the numbers of moles of each of the elements deposited, and this is representing what the charge of each of the what elements. That means, for those, remember, on the previous video I gave a situation whereby the metal is being what attracted to the cathode, and I drew a ionization. I drew a half reaction for that. The charge there, that charge and the mole of that what particular atom, the mole will be inversely proportional to the charge of that same what atom. So that means we are comparing them together. But in this case now, in the case of the second law, it's involving what more than one what electrolytic what cell or voltammeter. Okay, that's what it means. We are connecting two electrolytic cells together. So we are comparing the different mass that we produce on this one and this other one. Okay, that's what it means. So now, the numbers of moles of each of the atoms that we deposit in cathode will be inversely proportional to the charge on their ions. Okay, so now let's introduce the what and equality sign. So when there's an equality sign, let's call that when there is an equality sign, we introduce the constant of proportionality. Let's say this will be K. Let's call it K over what E. So now what does this mean? That N will not be, that means you use the constant of proportionality, make the constant sort of the formula. We have what K to be now be equal to what N E. That's the numbers of mole times the what charge. So now what does this mean now? Because in this case we are comparing two electrolysis, like we are comparing more than one electrolyte or a more than one electrolytic cell which will have different electrolytes. We are comparing them together. We're going to have two cases. So now if we have two cases, two electrolytes or even more, we can now say numbers of moles of first electrolyte times the what charge will now be equals to the what now? Numbers of moles of what second electrolyte times the what charge. If it's 3, you can also say equal to what now? Numbers of moles of the what 10 electrolytes times the what multiplied by the what the charge. So this is what the law is basically all about. Okay. So now, but I would not like to. I'm not like a situation where I'm comparing things together. Although it's possible, there is a calculation like that. Okay. So just think for that. But I'm going to prefer just to put it in this form. This is the formula that can be derived from what this second law. But this is what the second law is about. If the same quantity of electricity is passed to various electrolytes at the same time, the relative numbers of moles of each of the atoms deposited during the what electrolytic process is inversely proportional to the charge on their ions. Okay, so now that's what the laws of electricity is all about. So now moving to the second case, there is a term here used to describe the quantity of electricity when it comes to electrolytic process, and that is called Faraday. Okay, now I'm not referring to the man's law now. I'm referring to a constant that was named after him, a term that was named after him. So now, when we talk about Faraday in this case, Faraday is simply what the minimum, that the smallest amount of electricity that will deposit 1 mole of electrons. That will deposit 1 mole of electron from a substance in its molten or aqueous state. Of course, you know that's an electrolyte, right? Now, the minimum quantity of electricity that would liberate 1 mole, that's produce 1 mole of electron from a substance in its molten or aqueous state. Of course, you know what that substance is, electrolytes. Okay? So now, what we need to get from this place, what's the information that we need to get here so bad is that one Faraday here, there's a relationship between what Faradays and what's now the numbers of the moles of electrons. The moles of electrons. Okay? So now, one Faraday, before I relate to the mole first of all, one Faraday, this is Faraday, is a unit for measuring what? This Faraday now, this 10 Faraday is a unit for measuring what now? Quantity of electricity. Remember, from current electricity, or maybe let's say electrostatics, Q is measured in what now? Coulombs. You understand that, right? That's C. We call it coulombs. Also, you can also measure quantity of electricity in Faraday, or we can call it in Faraday. I see now. You can also measure quantity of electricity in what? Faraday. Just we can use what? Coulombs to measure what? Quantity of electricity. This is just another form of measuring the quantity of electricity, known as what now? Faraday. Okay? So now, but Faraday is related to what? Coulombs, because they are of the same units. Okay? So now, 1 Faraday is equal to what now? 96,500 coulombs. Hold on. One coulomb is different, okay? One coulomb is different. That means before you can get 1 Faraday, it's a unit of measurements, so be careful. Before you can get 1 Faraday of electricity, that means you have gotten 96,500 coulombs of electricity. By the time you have 96,500 coulombs quantity of electricity, that is equivalent to what now? 1 Faraday. Okay? With that being said, good. What implication, what relationship does the Faraday has with what? Ions. Now that's what I want to look at. Look at it now. This thing I can write like this. This 1 Faraday is also equal to what? 1 mole of what? 1 mole of what? Electron. 1 mole of electron. And it's also equal to what now? 96,500 coulombs. Let's start making facts now. So now, if I should write this same system again, I can write that it's 1 Faraday equals to what? E minus, which is 1 mole of electron, right? Equal to what? 96,500 coulombs. Okay? So now, this fact now has been what? This fact has been stated already. So now let's look at something. Let's look at some example. Let's say for instance we have calcium here. Calcium. Okay? We have calcium ion in electrolysis, I'm not talking about a normal ionization reaction now. I'm talking about a normal ionization half reaction. Okay? Now, normal calcium calcium ion is an electrolyte. So it wants to be deposited as the calcium atom back. So that it will have to what now? It has to become what? Reduced. Normally, in a normal ionization reaction, we lose electrolyte. You can see that in my previous video. So now, in this case now, I believe you already know what's happening here. If you watch the introductory video. So now it's going to what? Receive electron, which is not a normal situation for a normal reaction. Receives electron and becomes what? Reduced. So now it's going to be what? Plus 2E minus to give us what now? Ca, which is the solid to be formed. But we are not concerned with the product formed. Since we are talking about quantity of electricity measured in Faraday, we are not concerned with the amount formed. We are going to pay attention to just the charge that was what produced. We are also going to pay attention to 2 things. In this, when we are calculating, to be more specific, when we are calculating, we're only going to pay attention to the charge and the what amount formed, basically. So now, what in this equation now, what truth can we draw from this and half equation now is that we have 2 moles of what now? Electrons. In fact, one of the facts I'm drawing is that we have 2 moles of electron. In other words, since we have 2 moles of electron, automatically it means we have the 2 moles of what now? Electron. Fact. 2 moles of electron. What the fact now? It means 2 moles of electron is producing what? 1 mole of what? Calcium atom. We don't need to write one here. Okay? 1 mole of what now? Calcium atom. So if I want to write this in terms of what? Faraday, it's therefore that since I have 2 electrons here, 2 moles of electrons, it means I have what? 2 moles of what now? Faraday. I will see it now. Since we have 2 moles of electron, 2 moles of Faraday, now that is not going to happen. What will now be the implication? Since 1 Faraday is equal to 96,500, and 1 Faraday is equal to 1 mole. So now we now have 2 electrons here. That means we have 2 Faraday. So if you should look at the Faraday's constant, what is equal to? It's equal to 96,500 coulomb. That's for 1 Faraday. So that we have 2 Faraday here. What will it now be equal to? What quantity of electricity will these 2 Faraday be equal to in terms of what? Coulombs. These 2 Faradays will now be equal to what now? 2 multiplied by 96,500 coulombs of electricity. Since we have 2 farads, I will show you the heat now. So that this is the point we need to what? Take note of when we want to calculate, when we do our calculations on what now? Electrolysis. Well, these are the facts that need to be stated. First of all, in every electrolysis calculation, you will write out the half equation, then you pay attention to the charge and the mass that was formed. So now, since we have 2 electrons here, we are going to be having what now? 2 farad. And 2 farad will be equivalent to what in coulombs now? That will be 2 times 96,500 what? Coulombs. Okay? So let's look at another example before we call it a day. So now this for calcium. Let's say I have something like this. Sodium. What about sodium? Sodium, as usual, is ionic form. It's electrolysis we're talking about here. So now it's going to receive 1 electron. So it becomes reduced to what now? The atomic form, which is what? Sodium solid. So now from this now we have what? 1 electron. From this now we have 1 mole of electron. Means that's the information here is now 1 mole of electron is what's producing 1 mole of the what? Sodium atom. That means this also was 1 Faraday and is equals to what now? 96,000, because it's just one 96,500 what? Coulombs. Okay, that's it. So now another example. So now here, well, let's say we have a solution for aluminium. If aluminium is the case, now we have what? Al plus 3 as usual is in electrolyte form. So it's electrolyte, so it's a form of ion. So we are bringing it back to the atomic form. We've done with what? Receiving 3 moles of electricity, 3 moles of what? Electrons to come back to the atomic form. So we now have what? Al solid. Okay? So now it's going to receive 3 electrons. So now we're going to, as usual, we're going to pay attention to this and this. So now what are we having here now? Since we have 3 moles of electricity, that means from what we are having here, and the information here is that 3 moles of electrons rather is giving us 1 mole of what now? The atom. So now what can we also draw here? Now it means we have what? 3 Faraday here. Like I said, 1 Faraday is equal to 1 mole of electrons. So now these 3 moles of electrons now becomes 3 Faraday. And in this case now, what would be the equivalent of this Faraday in coulombs? Okay? What would be what now? Coulombs. What would be what equivalent in coulombs? So now be what? 3 multiplied by what now? 96,500 coulombs. Okay? So now with that being said, I think this marks the end of this video, and there will be a part 3 of this showing us how to do calculations on what now? Electrolysis. That will go by handling what? Calculations on what now? Electrolysis. Okay? So don't forget to hit the like and subscribe button if you are getting value from this, and I'm sure you are actually getting values from this. Okay? And see you on the next one.